We're surrounded by light literally every second of the day. But have you ever stopped to think about how it actually works? Like, how does it get from a light bulb or the sun all the way to your eyes? Well, it turns out its journey is incredibly fast and, believe it or not, surprisingly simple.
Okay, so take a look at this. We've all seen a scene like this, right? You're walking through a park on a sunny day and you see these long, sharp shadows stretching out from the trees. It seems pretty normal, but those shadows, they're actually hiding a huge clue, a fundamental secret about the very nature of light.
And here it is, the big secret. It all comes down to one simple rule. Light travels in a straight line. That's it. It sounds almost too easy, doesn't it? But that one rule explains, well, pretty much everything. It explains those shadows. It explains the beam from a flashlight. It's the absolute foundation. Now, of course, science has a fancy name for this. It's called rectilinear propagation. I know, it sounds super complicated, but all it really means is traveling in a straight line. And the best part is, the proof is absolutely everywhere you look. And this is what explains those tree shadows perfectly. I mean, think about it. When an object, like a tree, gets in the way of a ray of light, it just blocks it. The light can't just, swirl around it. So that whole area behind the tree where the light can't get to, that's what a shadow is. It's a light-free zone. Okay, so we've nailed down how light travels. Straight lines. Got it. But what is light, really? Well, at its most basic level, light is a type of wave. But it's not just any old wave. It's a very special kind. You see, not all waves are created equal. Think about sound. A sound wave is what we call mechanical. It needs stuff to travel through, like air or water. You can't hear someone scream in space, right? But light is an electromagnetic wave, and this is what makes it so wild. It doesn't need anything to travel through. It can just zoom across the total emptiness of space, no problem. And when it's in that empty space, oh man, it moves at an absolutely mind-bending speed. We're talking 300,000 kilometers. Not an hour, not a minute, but every single second. It is literally the fastest thing in the entire universe. Nothing's faster. All right, so let's do a quick recap. Light is a form of energy. It comes from vibrating particles. It's fastest in a vacuum. But, and this is a really important but, it actually slows down when it hits stuff, things like air, water, or glass. And that little detail, that change of speed, that's where things start to get really cool. So you've got this super fast wave zipping through the universe in a straight line. It's obviously going to run into things, right? So the big question is, what happens when it does? Well, it's actually pretty straightforward. When a ray of light hits any kind of material, only one of three things can happen. 1, it can be transmitted, meaning it just passes right on through. 2, it can be absorbed, where the material basically soaks up the light's energy. Or 3, it can be reflected, which is just a fancy way of saying it bounces off. So let's run through that one more time, super quick. Transmission goes through. Absorption gets soaked up. Reflection bounces off. See? Simple. Okay, now here's the cool part. Those three things, transmission, absorption, and reflection, they're not just abstract ideas. They're what we use to describe literally everything around us. They're the reason we can see clearly through a window, or see a blurry shape through a shower door, or not see through a wall at all. So first up, we've got transparent materials. These guys are the champions of transmission. They just let almost all the light pass right on through, no big deal. Think about a super clean window or a perfectly clear glass of water. You can see right through it, crystal clear. Then you've got translucent materials. Now, these are a bit tricky. They let light through, yeah, but they scramble it all up on the way. They scatter it. So light gets to the other side, but the image is all jumbled and blurry. You know, like frosted glass on a bathroom window? You can tell someone's there, but you can't make out any details. That's translucence. And last but not least, opaque materials. These are the total opposite of transparent. They are a brick wall for light. Light does not pass through, period. Instead, it's either absorbed, think of a heavy black curtain, or it's reflected, like a mirror. Your desk, your coffee mug, that wall over there, they're all opaque. And here you can see them all together, which makes it super clear. Transparent, you see everything. Translucent, things get fuzzy. Opaque, you see nothing. And what's so amazing is that every single thing in our world fits into one of these three boxes. It all just depends on what it does with light. And would you look at that? We are right back where we started, with our shadows. But now it all makes perfect sense, doesn't it? A shadow isn't actually a thing. It's a lack of a thing. It's the absence of light. It's just a spot where an opaque object, like a tree or you, got in the way of light's straight-line path and stopped it cold. This one basic idea, light traveling in a straight line, explains so much of our world. It's why a laser beam is a perfectly straight line. It's the reason you can't see around a corner. So here's a little challenge for you. The next time you're just looking around, maybe on a sunny day, try to spot other things that you can now explain, all with this one simple rule about the straight line journey of light.